Hello, fourth fans and future fourth fans. My name is Alex, and this is Advent of Code 2025 in fourth. So, a couple years ago, I did a video series also doing Advent of Code in fourth. But what's important to note is that there's different fourth systems. Fourth is a very low-level programming language. It's not a standardized programming language, and so each fourth is its own fourth, essentially. And DuskOS has a different behavior and different set of words than UF, which is the fourth system we're going to be talking about today. If you're not familiar with fourth, or you want to understand what I find interesting about the language, I recommend watching the first video in that series where I go over fourth generally. I'm going to start off this video before we get into the day one problem talking about UF specifically. So UF is a fourth that targets the UXN Varvara virtual computer. This is a 16-bit virtual stack machine created by Davin Lulin Vega, and it is essentially a virtual machine that is ported to many different systems that allows you to build small graphical audio and text programs. It's a very interesting project. I highly recommend looking into it in more detail. One of the things that makes it interesting for using fourth is sometimes people who do fourth, they get introduced through a system like G4th, which is very high level and somewhat bloated fourth, and doesn't really give you the sense of what makes fourth interesting. I think fourth essentially has to be, or should be, a low level programming language where you're very close to the machine and you have a lot of power over the machine. And a high level system like G4th doesn't necessarily do that. But to do low level programming can be overwhelming because there's a large gap if you're just writing directly to a chip. There's a gap between doing these sort of abstract systems where maybe you implement a bunch of toy problems, or you implement a fourth on a chip, but you don't really do anything particularly interesting with that. So UF is interesting because it's a graphical environment. It's a very simple environment. Davin calls it a fantasy computer in that it's unmired by the historical accidents and contingencies that make computers so complicated. You get to play in this playground that is very constrained and very interesting. So I recommend, if you're interested in fourth, I think UF is a very good way to both learn fourth, learn what makes fourth interesting, and also build something interesting, because you can start doing graphical programming relatively easily. So this is day one, secret entrance. Essentially, you have a dial. The dial starts at 50. You have a series of instructions where you rotate the dial. Left decreases the dial, right increases the dial, and the dial is 100 points. So for part one, you read these instructions and you want to see how many times the dial points at 0. And then in the second one, you want to do how many times the dial crosses 0. So how did I solve this? So we can start with solve here. So we put the initial dial count at the beginning. Then we iterate over all the input. Since we don't have, since we're always waiting for input, we have to set the number of times we iterate ahead of time in the UF system. Then we iterate over each line. We execute the turn, which is the value in the string, and then we get the values in password for part one and password B for part two. So the first thing we need to do is extract the value out of the string. That's what this function does. We read the string here via query and tibs, which will read all the input past the end of this file into an input buffer and then give me access to that string. And then the way that I run this is I essentially just concatenate this file with the input afterwards, and it's just going to like read the rest of the stream. So so once we do that, we then parse the value using turn val. So turn val is going to get that instruction and convert it to an integer that's either positive or negative. The way we determine whether it's positive or negative is through, so the letter O is the midpoint between L and R. And so if you subtract that value and divide it by 3, you can get positive 1 or negative 1. Multiply that by the rest of the string, which I use this string to number function to convert. And then you have converted the instruction to rotation. So once we have this rotation, we then put it on the return stack and then add it to the function, or sorry, add it to the number that's on the stack, which is the dial. Then for part 1, which is down here, we constrain that number to be within the range of 0 to 100, which uses wrap 100, which uses floor mod, which is a utility function that I wrote because the mod that's built into UF doesn't behave like the mod that you're going to want for this problem, because negative numbers don't modulo, like negative 18 should be modulo 82, but it's modulo 18 in UF. So I just had to write a floor mod that behaves like Python's modulo operator. And then if it's 0, if the modulo is 0, then we add 1 to password, and we just iterate, and we're iterating over all of the turns here. For part 2, what we want to do is we have this essentially, so I did a little research, I cheated a little, read a bunch of Python functions and kind of converted it to Forth. But essentially what we're doing is we're doing a floor mod of, wait, this is a floor division, not a floor mod. This is a floor division. Okay, so we have our floor division here, which we then basically just say, okay, how many turns are there between the old value and the new value, and then add that together. Now the weird part, if you ask me to explain this, I will not do it very well. But essentially, you want to make sure that you're not double counting the start and the end if you land on 0. And the way that I saw people do this is you just, if the value is less than 0, you subtract 1 from both values and do the same logic. So this essentially gives you like the number of turns that you have, and fixes the off by 1 issues. And that's how you do part 2. Yeah, that's it. If you're interested in my solution, link to the Git repository is in the bio, and I look forward to seeing you in the next video. Take care.